So the different aspects of the program, we haven't discussed that often, but I have 10 different performers that are working with us in the active authentication in the first phase of the program. Now, the first phase of the program is focused on working in new areas of biometrics that don't require sensors and proving that it works with real people. The end result of this is not developing an application. DARPA is not trying to develop an application that does what these various things do. We're just trying to say this is really going to work on real people so we can have proof at the end this is really valid. The first area, we have a senior government executive in the Naval Postgraduate School who has been working for some time in various areas on neurocognitive patterns that she believes. Basically, the theory she has that she's been working with is that when people make decisions, they go through a set of rules that are built into your head. The concept of a series of rules and information built in your head is similar to how a computer follows instructions. If we can determine a pattern in how computers do that, she believes it's possible that we should be able to find the same type of patterns in how we come to our own decisions, and that could potentially be the source from which behavioral biometrics come. So if this works, if the neurocognitive patterns can be determined the way she thinks it can, then we may be able to actually find a framework from which all behavioral biometrics are and find additional behavioral biometrics, because you have a similar set of thought processes, and this goes down to individuals. Even twins would have a different way of thinking about things simply because the perspective of one twin being to the left and one twin being to the right will change the environment in which they make their decisions. Now this is a DARPA type thing, so it's a really long shot idea. We're not expecting to see a product that comes out of this. We're trying to push research forward to say, is this possible? Can we go forward on this? Another area we're looking in, we have Allura Security Technology, who's working on finding individual features of a biometric in user search patterns. They've done some preliminary research that suggests that when there's high volumes of a high density of documents touches, that they can find a pattern in which you dig into information, that I pull information differently than you do when you're doing user searches. And we're hoping that obviously this would not be a biometric that could even come close to comparing to fingerprints, but the purpose of the program is to move biometrics in all the different areas of things we do. So when we're doing searches, we pull information back that will increase the fidelity it is you. We have BehaviorSec working with us, who's taking their keystroke dynamics and expanding it to include mouse dynamics so they can have use the same type of timing information that's typically done in keystroke biometrics and also expand out to mouse biometrics. We have Coveros engaged, now Coveros is an IDS vendor. They do intrusion detection systems. And intrusion detection systems look through streams of information on the network trying to find a pattern. When they looked at this, they said, wait a second, on your computer when you're working, there's a stream of information going between you and the computer. So they say, well, they believe that their technology of finding patterns and streams of information across a network may be able to define individuals when you're working and interacting with the computer itself. And they're looking through what they call user behavior patterns from the operating system's perspective. Again, this is not necessarily coming out with an application, but it's definitely a different way of looking at it, and it could come up with a biometric we had never even discovered before. We have three performers working in the stylometry area. Drexel University is using more traditional stylometry methods, such as tracking things like user frequency and the type of punctuation you use and various other things, but they also have the difference that they have a plan built into theirs where they have a way to determine when someone's trying to impersonate someone else. So if I'm sitting down at a keyboard and trying to type like someone else, there are patterns in their tells that they believe they found, and they've done some preliminary research and published some papers on the subject that seem to suggest that they have a good chance of developing a more mature solution here. We have Iowa State University, who believes that they can develop a stylometric solution that will work not based on what you're typing, but based on how you're typing. For example, when you're typing a noun or a preposition, there are certain patterns in which you have pauses, because typically when you're typing, you think about what you're typing. Some people might type the and just keep on typing faster and pause at certain punctuation points. They believe that there's enough information in there that they can find enough features to develop a biometric from that. We have NYIT on board, who is using another stylometric solution where they're using what they call more text productivity, where they can tell how the information you're typing a 3-letter word, a 4-letter word, a 2-letter word, and they can even ignore language. They don't have to pay attention to language, just they pay attention to how you're typing and where the pauses are and how you interact with it, which will give us a stylometric solution that can be language agnostic. So it doesn't matter what language you're typing in, it still can identify who you are. I also have on board Southwest Research Institute, who's working with a more interesting area. I refer to it as covert games. If I can give you an example, everyone's familiar with, you have an old car where you may have to turn it over a certain way and kick it and do things to get it. There's a certain pattern you have to use. They consider that a game the car is teaching you. We have to do certain things to get it to work properly. What they're going to do is they're going to take the operating systems, the graphical user interface, and change attributes of it to build games into that sort of thing. The example I use when discussing it with discussing this program is, if you move a window up to the upper right-hand corner of the screen and you click on it, you have to triple click it instead of double click it to close it. After a time, if this pattern is established, you'll get used to these certain games of how to use it. You always triple click when it's the upper right-hand corner. You may double click when it's the lower left-hand corner. But an adversary coming in is going to react differently than you are, and they believe the difference in behavior is going to be enough to use that as a biometric to determine when you're there versus when someone else who's pretending to be you is there. University of Maryland is looking for something also very different as well. They believe that the way we take information in and process information is unique on a personal basis. So they're going to focus on the screen information itself. For example, some people may put icons all over the screen and put windows here and windows there. They think that is represented enough to give us some information, again, not as accurate as a fingerprint, but some information on the characteristics of the individual. We really like this biometric solution because if you take a wounded warrior who comes back from a war zone missing a limb, they're obviously not going to type the same as they did when they were going before. Then it may have the physical damage they have, but they're still going to process information the same way because the information comes into the mind. So hopefully if this works, now this again may be a stretch goal, but if it works, it's a great new biometric that doesn't exist now. We also have with us the Naval Research Lab, who's coming on their own. This is a project that was funded by the Naval Research Lab, that they're working towards the same type of goals, and they joined with us so we can get some collaboration between us and the Naval Research Lab. They're doing web-based analytics. They believe the way you do web processing, the websites you go to and how you go through it, gives contextual information that can give you information to tell the individual. You may go to a business site when the first thing you get in the morning. When you get around lunchtime, you may go to your social networking sites and things like that. You may go to check a financial accounting thing. There are various other things that they can tell from the context of the information you put in, which just comes off in the web stream from the machine itself. And that's the last of the performers we have. Well, one of the challenges when you're working on a DARPA program is you create new technology and it doesn't exist before, which makes it challenging when you're trying to transition it to the warfighters. So one of the things I'm focusing on early on, and that's why I'm doing this discussion now, is try and increase awareness of the technologies we're working on and what we're trying to do so that the policymakers who are trying to establish policy can develop policy to allow for this type of solution to be used in the first place. So that the people who have credit systems can understand how they could develop methods by which they're accrediting, and we're going to try and partner with NSA in the future to try and bring an accreditor on board so that they can understand how this solution works, so they can develop rules of how you do your accredited system that goes there. So that the people who would end up operating the system, the CIOs inside the Department of Defense, can have understanding of how would you acquire this, how would you integrate this, because those are all critical aspects of how you get a DARPA program to work that have to be addressed at the very early stages. And a key part of that is people understanding what we're doing, and that's what this is doing here. We're trying to discuss now this DARPA program so that there's increased awareness inside all those communities and reach out to the policymakers, the accreditors, the operators, the various communities of interest that are associated with getting an actual product in the hands of the warfighters and helping to defend our computers. Good?
How long is phase one?
Phase one is 1 year. And then okay, I actually want to go over those things. Okay, the first phase of the Active Authentication Program, which has the performance I've described, it started in June and extends for 12 months. At the end of that, there's research papers that they're going to provide the scientific community evidence that these solutions work. We're planning in the winter months of this coming winter to put out phase 2, where we'll develop a platform and integrate several biometrics into a solution that can actually be deployed, and we can show DoD somewhere that this actually does work, to make it a pilot, if you will, of the solution. Then that process will extend about 2 years.